Hey everybody, the particular problem I'm going to work today is similar to a problem that was represented as a Cambridge, I guess, entrance exam question by a math channel, a YouTube math channel stated this in the thumbnail but made no reference to it in the video. So anyway, I'm going to work one that's similar to it with larger constants. Now, this is an example of an exponential equation. And it's called that because the unknowns are exponents. Now, we have 5 appearing here, but here we have the square root of 5. And the first key observation here is to note that the square root of 5 has a fractional exponent representation. We can write it as 5 to the 1/2. And it's one of the most confusing things in math because what happens is they leave out important things here because this is such a popular symbol. They don't write the 2 or the 1 here most of the time. It's omitted, but this is the general structure. If you have m and n, then you can write this as m over n, or the other way around, n over m, whatever. But anyway, this particular convention is why we can go from here to here. Because notice all we did was multiply this 1/2 times x plus 6, or divide x plus 6 by 2, and you get this statement right here. See, folks, how the square root of 5 changed to 5 because we can actually rewrite the square root function, the square root value like this. And then there's a property that says you can multiply exponents. Okay, so that takes care of this very first statement, which simplifies things immensely because now we have the same 2 bases. Okay, now so right here, all you have to do is observe that 125 is 5 cubed. Which is exactly where this 3 is coming from right here, okay? And again, there's another property that says, if you think of this as 5 cubed times 5 to the raised to the x over 2, you can sum the exponents, okay? Another property of exponents. Okay, now we get to this stage here, which is fairly useful. A lot of people might use a substitution right here, but it's useful to notice that you can think of y to the 5 to the x is y squared, and 5 to the x over 2 is just y. And again, you can envision squaring this, then you multiply the exponents together, which ends up canceling the 2, and you have this. So this is in quadratic form in the variable y. So again, a lot of people will go to the trouble to do a substitution. I think it's kind of clumsy and a little bit of a crutch. So what we're doing, we're looking for a pair of numbers that sum to minus 125 and have a product of 3750. It doesn't take long to note that those 2 numbers are 50 and 75. $50 times 75 is 3750. Now again, this is super useful because since this is equal to 0, there's something called the zero product property that says both of them have to be equal to 0. One or both of them have to be equal to 0. So this would tell us that 5 raised to the x over 2 would have to equal to 50. Again, you're equating this to 0, then taking 50 to the other side. And similarly, on the other side, you'd have 5 to the x over 2 is equal to 75. Now, this isn't good enough for an answer. We've made some progress, but we need to get x isolated somehow or another. And the way to do that is to take the log base 5 of both sides. All right. So if you take log base 5 of both sides, let me just. If you take the log base 5 of this, you just get x over 2. Log base 5 and the exponential 5 are what they call inverse functions. And so now you have this is equal to log base 5. And again, folks, the logarithm function and the exponential function are inverses. And if you carry on in a similar fashion right here, you get x over 2 is equal to log base 5 of 75. Still not done. Now I'll do two steps in one here. If you multiply by 2 and then use another property of exponents, you get x is equal to log base 5 of 50 squared. And again, that's another property of logarithms that says powers become exponents. And of course, something similar over here, x is equal to log base 5 of 75 squared. Okay, folks. Now, I'm totally satisfied letting people leave the answer like this. However, some people like to change the base to a button that appears on the calculator. So I'm going to do that, and you can write this as this is called the change of base formula, natural log of 50 squared. You can use common log if you want to, whichever button you want to press on the calculator. And this is also equal to ln of 75 squared over ln 5. Okay, so these would be your two, these are the answers. Okay, I'm not going to go to the trouble to scribble down the decimal representation of all that. But y'all, in terms of estimation, notice that 5 squared is less than both 50 and 75, right? But both of those are less than 5 cubed. So you see, you can get some estimates here pretty quickly, meaning that both of these, after you take the logarithm, would be a number between 2 and 3. If you take the logarithm of both sides right here, you get 5 is less than the log of 50, log base 5 of 50, log base 5 of 75, it's all less than 3. So these numbers would be trapped between 2 and 3, and then when you multiply by 2, the both numbers would be between 4 and 6. Okay, and I won't finish that off, but you can. This statement right here is a starter to giving a nice estimate for both numbers. Both numbers would be between 4 and 6. In other words, I'll just write both of these numbers are between 4 and 6, without needing a calculator. And it follows from this statement right here. Between 4 and 6. Now, some teachers will ask you to do estimates so that they know you're not just trusting that little magical box in your hand. But and again, I think it's very common due to time constraints just to leave the answer like this. But both of the answers would be between 4 and 6, with this as your starting point for your estimate. All right, that is all, folks. Thanks for viewing.